Hello. Hello dear students, everyone. Pleasant evening. Welcome to Sri Chaitanya Bridge classes. How are you? How are you guys? How are you boys and girls? Right. So today's lecture we are going to see matrices, and today and even the next class also matrices, determinants, related important points. Right. Hope you are all doing well, practicing the questions that we have been discussing here and recollecting the important points. So far in our previous lectures we covered, you see, importantly modulus functions, related properties, problems, step function, fractional part function, even we have seen transformations of graphs, then sequence and series, arithmetic progression, geometric progression, harmonic progression, most importantly the inequality related to AM, GM, HM. So all of you dear students from previous days lecture, can you, yes, thank you, yeah, all of you say number, 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 good evening, number. Number is the ruler of the universe, right? Number is the ruler of the universe, correct? Thank you. So I am really connected, the students who are continuously following my classes, number, thank you very much, thank you, yeah, right. And then we have seen some patterns, most important takeaways from yesterday's class, AM, GM, HM inequality. All of you please text for positive numbers AM greater than or equal to GM. All of you please text, all of you, non-negative, correct? Number is the ruler of the universe. Lovely dear students, thank you very much. Yeah, I mean to say all of you please text, yesterday's important takeaway is all of you please text AM greater than or equal to GM. Text, let me see, AM greater than or equal to GM. AM greater than or equal to GM, right? Thank you. Very nice. AM greater than or equal to GM is the important takeaway from yesterday's class. Yes, AM greater than or equal to GM, which is greater than or equal to HM. Most important point is, if all the entries are equal, AM is equal to GM is equal to HM. If at least one entry is different from other, you will get AM strictly greater than GM, which is strictly greater than HM. That was the important, those two were the important points that we discussed yesterday. Now dear students, now let us come to a very important one, very introductory. Some students of CBSE, maybe matrix is very new to you. This is a very important one. It is what we call modern algebra, and you know matrix, you take Excel, MS Excel and all these things, it is nothing but a matrix kind of. So in computers and all, matrix applications are huge. This is why in JEE part, I think all of you know, in JEE advanced exam, so in mains there is no qualifying subject wise, qualifying mark subject wise. Suppose a student got 10 marks or 1 mark in math, 1 mark in physics, 100 marks in chemistry, his total is 1 or 2, he will get some rank. But in JEE advanced exam, you have to take a minimum score subject wise. So in that case, you need to focus on certain important topics. Then we always suggest to focus on matrices and determinants. So such an important topic it is. So all of you dear students, take this topic, and moreover this topic is very easy, even very easy, right? So shall we start dear students? Matrices is a superb easy topic, very important topic, both are, okay, right? Are you getting my point everyone? Clear? So in JEE advanced, suppose the paper is P1 P2 will be together, suppose 120, generally it will be announced after the exam, minimum 10 marks you have to score out of 120 in each subject, okay, around 10 marks, right? So that is fine, but you people are going to do miracles, you no need to worry about minimum marks, but do remember at the same time it is not that easy. That is speciality of JEE advanced exam. So one has to focus on certain important and easy areas which bring you wonderful marks. So dear students, most important point everyone do remember, matrices is an important come easy topics. If you ask me to tell me one important chapter out of all the 30, I'll first suggest matrices and determinants. So we shall move to matrices. Okay, all of you text matrix. Yeah, all of you text matrices or matrix. Matrix you text, all of you. Matrix. I am asking you to text because I want you to involve in the discussion. Matrix is singular, matrices is plural, right? Please all of you text. I'd like to see your seriousness here. Yeah, it gives me a lot of energy to deliver the lecture, right? Fine. Chalo. So first let us define a matrix. Friends, matrix is very simple, a rectangular arrangement of numbers in rows and columns. For example, you see, let me take this arrangement 2, 3, 5, -1, 0, 11. This is a matrix. You see, here I have written certain numbers in rows and columns. Rows means, you know, horizontal ones are called rows. 2 rows are there. Vertical ones are columns. There are 3 columns. In this arrangement, there are 2 rows and 3 columns. So we say that its order is 2 by 3. We should read it as 2 by 3, dear students. 2 by 3. 2, not 2 into 3. 2 by 3. It denotes number of rows. This denotes number of columns. Generally, matrices are denoted by capital letters like A, B, C. Okay. So this is a matrix. Okay. So matrix is generally we can also have, in a matrix the entries always need not be numbers, they can be names, they can be elements or something, but our discussion restricted to numbers. Okay, so what is a matrix? So in this class, some students, those who have studied SSC, may feel like matrix is very easy, but I'll definitely going to tell you certain important points which you don't know. Okay, stay connected. Initially it seems to be very easy, but definitely I am going to cover some interesting points. ICSE, okay? Yeah, some interesting points which you don't know about matrices. So stay connected with us. So this is a matrix. What is it? So let me take one more example here. What is a matrix? All of you, let me take a matrix B, like arrangement of 3, 1, 4, 6, -1, 2, 0, 4, 5, 3, 1, 2. You see, in this arrangement of numbers, what is the order of this matrix? Come on, please text. What is the order of the matrix? Come on, text. What is the order of the matrix? Text, let me see. How many rows are there? There are 3 rows and 4 columns. So order of this matrix is 3 by 4. Order of this 3 by 4, not 4 by 3. 3 by 4. Fine, good. 3 by 4. And interestingly, suppose this element is not there. So what about this element? What should you assume that what element is here? What element is here? What element is here? If no element is written here, what should I assume? No element is here, what should I assume? I mean to say, no, 0 is not correct, because if certain entry is not filled, it is not a matrix. 0 is not correct. 0 is not correct. It is not a matrix. It is not a matrix. Please do remember, it is not a matrix. If some entries are missing, it is not a matrix. Don't assume like there is 0. Okay, so this is not a matrix. There must be some element. Okay, that is point number 1. Number 2, here address of an element. You see, this element is in first row and first column. So I write A11 as 3. 1 1 means the element which is in first row and first column. Suppose you take this element, it is in second row, fourth column, A14 we call, A24. Second row, fourth column, A24 is 4. Correct? A24 is 4. Now, suppose if you want to name this particular element's address, it is in third row, first column, A31 is 5, whereas A13 is different, first row, third column, 4. Got it? This is what we call address of the element. Clear? So, element Aij, what does it mean? Element Aij stands for the element which lies in ith row and jth column. Clear? The element which lies in ith row and jth column. Correct? Correct? Ith row and jth column. Correct? Fine? Yeah. So, after introduction, here I mean to say point number 1, what is a matrix? A matrix is a rectangular arrangement of mn elements in m rows and n columns. A matrix is arrangement of certain elements in rows and columns. This is called order. Matrices are denoted by capital letter. Second point, an element Aij means it lies in ith row and jth column. These are the 2 points I have covered. The next, size or order of a matrix. I have already told you, suppose if I take a matrix like 3 minus 1 4 6, what is the size of this matrix or order of this matrix? Come on, what is the order of this matrix? There are 2 rows and 2 columns, and hence we call it as a 2 by 2 matrix. Okay, this point you know. Now coming to types of matrices based on the order. Types of matrices based on the order. Types of matrices based on the order. Friends, generally if you take a matrix of order m by n, okay, in this first we can say, by observing the order of the matrix, we can say a matrix is said to be rectangular matrix. Rectangular matrix if number of rows different from number of columns. Number of rows different from number of columns. Example, I can say here, you see 2 1 4 6 3 1 minus 1 4. You see 2 rows 4 columns. A 2 by 4 matrix. Rows and columns, if they are different, we can call it as a rectangular matrix. Second one is square matrix. A matrix is said to be square matrix if number of rows is equal to number of columns. For example, 3 1 minus 1 3 something. A matrix for which rows is equal to column. It is a 2 by 2 matrix. So it seems like a square, so it is called a square matrix. So a square matrix is that for which number of rows is equal to number of columns. Okay. So this is square. Then third, friends, you can say a row matrix. Row matrix in the sense, a matrix for which there is one and only one row. For example, you see matrix 3 minus 1 4. This is 1 row 3 columns. 1 by 3 matrix for which there is only one row. So we can say like m value is 1. In the order, if number of rows is 1, we call it as a row matrix. Okay, number of rows is 1, we call it as a row matrix. The next fourth, column matrix. Column matrix. A matrix is said to be a column matrix if it is having only one column, n is equal to 1. For example, minus 1 3 6 you take. So 3 rows 1 column. If it is having 3 rows 1 column, we call it as a column matrix. So types of matrices based on order. There are 4 types. which is rectangular matrix, square matrix, row matrix, column matrix, correct? Rectangular matrix, square matrix, row matrix, column matrix. Rectangular is simple, rows, columns must be different. Square is different, rows, number of columns must be equal. Row matrix means it must have only one row. Column matrix means it must have only one column. And there are certain terms like horizontal matrix, vertical matrix, not required, all those things. I don't want to add unnecessary definitions, this is fine. So clear, types of matrices based on order. After this, dear students, yeah, try to answer this question, all of you, try to answer. Construct a 2 by 3 matrix whose elements are given by this definition. Right, everyone, all of you try. You have to construct a 2 by 3 matrix. Definition is given. 2 by 3 matrix means it must have 2 rows, 3 columns. That means first row means 1 1, 1 2, 1 3, 2 1, 2 2, 2 3. So why can't we write like this, guys? So a 2 by 3 matrix will be in this format. Correct, everyone? Correct. Now A11, use this definition. Aij means A11, I is 1, j is 1, that is 2 plus 1, 3, 3 square is 9, this is 9 by 2. A12 in the sense, I is 1, j is 2, you see, 2 plus 2, 4, 4 square is 16, 16 by 2 is 8. 1 3, I is 1, j is 3, 2 plus 3, 5, 25 by 2, 25 by 2. A21, come on, very good. A21 means I2, J1, 4 plus 1, 5, 25 by 2 it is. Yeah, next A22, I is 2, J is 2, that is 4 plus 2, 36 by 2, which is 18. A23, this is 4 plus 3, 7 square, 49 by 2. So, dear students, a matrix can be given in this format. A matrix can be defined in this way. Order is given, Aij general definition is given. Do you understand how to write the matrix? Is this clear? Is this clear? Those who know, those who understand this, all of you say, yes sir. All of you text, yes sir. Yeah, they can be in decimal. They need not be integers. They needn't be always rational numbers. They can be even irrational. They can be even complex numbers also. In fact, entries of a matrix needn't be numbers even. Okay. Yeah, someone are asking to write one more example for you. Let me take one more class, one more example. Let me write here. Okay. So once again, suppose A is a 2 by 2 matrix. A is a 2 by 2 matrix where entries are defined by Aij is equal to I square plus j. Some definition is given. Now all of you try. Everyone. A is a 2 by 2 matrix means it contains 2 rows, 2 columns only. So A11, A12, A21, A22. This is the point, right? So college when will be open? It will be informed to you through our principals. You will get a call about this, okay? Right. So A11, A12, A21, A22, okay? A11 means this is Aij, I1, J1, put here 1 square plus 1 is 2. Yeah, I am repeating, please see here. A12 means I value 1, J value 2. This is 1 square plus 2, which is 3. A21 means I is 2, J is 1, 2 square plus 1, 5. A22 means I is 2, J is 2, 2 square plus 2, 6. This is the matrix. So, yeah. So, this is the point, dear students. You can see here a matrix sometimes be given like this. Okay. So, you can write the matrix comfortably. Fine, everyone. So, after this, you try to answer this question. Yeah. Yes. Why will they give like? Yes, they will give some definition. A is a 2 by 2 matrix where Aij will be defined with some definition they will give. Accordingly, we compute. If they give like I square plus j cube, it will be changed. Got it? Got it, Amma? Fine. Chalo. Now, you try to answer this question. I know some of you could definitely answer this. The number of different matrices of order 3 by 3 whose entries are either 0 or 1. Can somebody answer please? Quick. Try this question. That means how many 3 by 3 matrices can be written where entries can be 0 or 1. 3 by 3 means there must be here 3 elements, here 3 elements, here 3 elements. 9 elements are possible. Now, how many different matrix can be written? The entries can be 0 or 1. Any entry can be 0 or 1. Can anyone? Let me see really how many can answer. Quick. You mean 9 matrices? You mean 9 matrices? No. Check your answer. The answer is not 9. Answer is not 6. Nageshwar Rao, your answer is perfect. 512 matrices we can write, Bhaiya. 512 matrices we can write. Let me show you one of the matrices. Let me write a matrix where all entries can be 0. Is this a matrix? Clear? It's a 3 by 3 matrix. It's a 3 by 3 matrix where every entry is 0. This is 1. Let me write another 3 by 3 matrix where I put this entry is 1 because any entry can be 0 or 1, right? Now this next time I will write 1 here 0. Next time this 1 can be at any of the 9 places, right? Now there may be 2 1s, there may be 3 1s, there may be 4 1s, 5 1s, all 1s like this. So many will come. So definitely here, dear students, some knowledge of permutations will help you. You see, this place can be filled in 2 ways, either 0 or 1. 2 ways you can write. This place can be filled in 2 ways, 0 or 1. Now this and this you can write 2 into 2, 4 ways. You know what are the 4 ways? Both can be 0, 0 1, 1 0, 1 1. Correct? 2 places you can fill in 4 ways. Am I correct? 2 into 2. 3 places, this place can also be filled in 2 ways, 0 or 1. So 3 places you can fill in 8 ways. You know what are these 8 ways? All 0, 0 0 1, 0 1 0, 1 0 0, 1 1 0, 1 0 1, 0 1 1, 1 1 1. Got my point? Every place can be filled in 2 ways. So now if you take 3 places, 2 into 2 into 2, 8 possibilities you got. Am I correct? Everyone, please respond. Correct. Do you understand this point? If you take 3 places where each place can be filled in 2 ways, can I say that this row can be filled in 2 cube ways? Correct. Now you extend your answer. Now 4 places in how many ways I can extend? How many ways can I fill? This in 2 ways, 2 ways, 2 ways, 2 ways. This is 4 places. How many ways? How many ways? 2 into 2 into 2 into 2. 2 power 4. Very good, very good. 2 power 4. 2 power 4. If you take 5, 2 power 6, 2 power 7, 2 power 8. Means 6, 7, 8, 9. Finally, you will get 2 power 9. 2 power 9. It is 2 power 9. Got my point? Clear? Clear? How many of you liked this problem? How many of you like this problem? Yes, in a matrix the entries can be negative integers, rationals, irrationals, complex numbers, whatever it can be. Right, very good. Now just let me change the question a bit, try to answer. Let me change a problem a bit, let me see how many of you can answer. How many of you can answer? You see, number of different matrices of order 4 by 4 of order 4 by 4 whose entries can be 0, 1. Come on, come on. 4 by 4. How many matrices we can do? 4 by 4. 4 by 4 matrix will have how many entries? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. Each place can be filled in 2 ways. Yes, correct. Thank you very much. Superb answer. Superb answer. 2 power 16 is the right answer. 2 power 16 is the right answer. Very good, very good, very good, very good. Let me change the question. How many 3 by 3 matrices can be written where the entries can be 0 or 1 or 2? Now you try to answer. How many 3 by 3 matrices can be written where the entries can be 0 or 1 or 2? 0 or 1 or 2? 0 or 1 or 2? Come on. Arey yaar, many of you didn't like the video. Didn't like the video. Forgot to like the video. Huh? Yeah. Right. In this case, you are absolutely perfect. The answer is 3 power 9. That's what JEE is. This is a routine question. We push the question into some little bit change. You see, that can be like 3 power n, 3 cases. The same question, it is changed like 4 by 4 or 3 cases like that. Got it, everyone? Clear? Superb. Well done, dear students. I must congratulate all of you. You are excellently following. Superb students, you are all superb following. So I am very happy, right, for your responses. Next, dear students. Now, principal diagonal. Let me define a principal diagonal in a square matrix. Okay, so square matrix in the sense, you know already I told you, a matrix in which number of rows is equal to number of columns, we call it as a square matrix. So now if you just see, this diagonal is called, there will be 2 diagonals generally, this also, but this diagonal is called principal diagonal. Okay. Okay, Harshit, I can understand English, man. Still, so the class started, still how many classes are there? Means I am asking from the class started till now, how many classes are there? Please respond. So many classes are there. Okay. And many classes are there. In your question itself, answer is there. How many? Many. Okay. Yeah. Chalo. Principal diagonal. Principal diagonal is this. Clear, everyone? So especially, you see, let me take a 3 by 3 matrix. All of you see this. Let me write A11, A12, A13, A21, A22, A23, A31, A32, A33. This is a matrix, 3 by 3 matrix. Okay, this is a 3 by 3 matrix. Now we define this diagonal as the principal diagonal. Okay, this diagonal as the principal diagonal. You see, you can observe one point here. In principal diagonal, Aij in principal. If you see, observe, the elements are like Aij where I is equal to j. Am I correct? So the elements are like Aij where I is equal to j. Okay. Now, one more observation here. All of you listen to me. Very, very important observation. The elements above the principal diagonal, you just observe the suffixes Aij such that I less than j. Am I correct? For the elements above the principal diagonal, the elements are like Aij where I less than j. Okay. Now, the elements below the principal diagonal will have Aij where I greater than j. Do you observe this point? In the later, in defining certain matrices, we use this terminology. So you must remember this, dear students. So what do you mean by principal diagonal? Come on, all of you. A principal diagonal is a term which is defined in only square matrix. In a rectangular matrix, there is no meaning what is a principal diagonal. Okay. So principal diagonal means the elements of, yes, let me repeat, Nageshwar Rao. Principal diagonal means this diagonal, simple. So generally, you see, in the principal diagonal, the elements like Aij, I is equal to j will happen. For the elements above the principal diagonal, I less than j will be for Aij. Below the principal diagonal, I greater than j will take place. Correct, everyone? Got it? Got it? Fine. Yes, I am going to give you important points. From here, important points come. Stay tuned to the class. Don't leave the class. Very, very important one. Yeah. Now, already, Arey Shiva, what is there? Principal diagonal is this. That's it. Simple point. Nothing to worry about it. Now, types of matrices based on the principal diagonal. Types of matrices based on the principal diagonal. For example, dear students, first one is, listen to me carefully, types of matrices based on the principal diagonal. First one is, yeah, upper triangular matrix. Upper triangular matrix. A matrix is said to be upper triangular. You see, example, let me write here. This is 7, 0, 5, yeah, 8, 1, 7, 0, 0, 0, something. You see here, for a matrix, this is the principal diagonal, you know. If the elements below the principal diagonal are 0, we call it as upper triangular matrix. Come on, what do you mean by upper triangular matrix? A matrix is said to be upper triangular if the elements below the principal diagonal are 0. It doesn't mean that above there shouldn't be 0. Some elements may be 0, that is fine. But the point is, if the elements, yeah, no problem, Harshit, no issue. Yeah, so don't worry, I take it very light. Okay. Yeah, the elements, if the elements below the principal diagonal are 0, we call it as upper triangular matrix. Okay. Similarly, lower triangular matrix, in the sense, lower triangular matrix, yeah, is that for which, you see, this is 1, 6, 5, 0, 0, 0, 0, 7, 4. If the elements above the principal diagonal are 0, we call it as lower triangular matrix. This is the example of upper triangular matrix. This is the example of lower triangular matrix. Okay. It's very simple, Nobita, don't worry about it. I'll explain that. Yeah. You see, what are you saying? If zeros are upper from PD, then yes, if the zeros above the principal diagonal are 0, we call it as, the elements above the principal diagonal are 0, we call it as lower triangular matrix. Below the principal diagonal are 0, we call it as upper triangular matrix. Clear? Now, triangular matrix means, triangular matrix. A matrix is said to be triangular matrix. That means either upper triangular or lower triangular can be called as triangular matrix. Triangular matrix means it must be either upper triangular or lower triangular. Got it? Got these points? Don't worry much. Now and then we use these terms, that's it. But most importantly, this is very, very important. Diagonal matrix. Diagonal matrix. Friends, if a matrix is like 5, 0, 8, 0, 0, 0, 0, 0, 0. Yeah, this is a matrix. A matrix for which the entries other than in the principal diagonal are all 0, we call it as diagonal matrix. We also write it as diag 508. That is the meaning. Diag 508 means it is a representation. Diagonal matrix 508 means, okay, 3 elements are there, it is a 3 by 3 matrix. You write 508 here, remaining all 0. Got it? What is diagonal matrix, everyone? Diagonal matrix means in the principal diagonal some elements will be, other elements will be 0. Got it, everyone? Clear? Diagonal matrix. Diagonal matrix. Yeah. Triangular matrix is simple, Ammu. It is, triangular matrix means either upper triangular or lower triangular. Okay. Yeah, fine. Okay. So principal, here there can be some zeros, no problem. It can be 10, no problem. Okay, we can also write. If some elements are 0, no problem. You may ask, sir, what if some, that means some student will understand like the elements other than the principal diagonal are 0 means they feel like in principal diagonal there shouldn't be 0. There is no such point. Okay. So the point is, dear students, these elements must be 0. Here whatever are there, we don't worry. Here it can be zeros also, no problem. Clear? Clear, everyone? This is diagonal matrix. Next one is scalar matrix. Scalar matrix. A matrix, scalar matrix is almost like diagonal matrix, but all entries are same in the principal diagonal. Remaining all entries must be 0. So you see, diagonal matrix kind of, but in the principal diagonal all entries will be same, remaining all will be 0. It is called scalar matrix. Scalar means always number. Scalar means number. So it is a number, all entries are equal. The next one is going to be unit matrix, which is also known as identity matrix, because it acts as multiplicative identity later. This is nothing but almost like scalar, but specifically the principal diagonal elements must be 0, all the other principal diagonal elements must be 1, all the other elements must be 0. Okay? Yeah, correct? Correct, everyone? So you see, these three are of one kind. You see, all these once again based on the principal diagonal. What do you mean by principal diagonal? In a square matrix, this diagonal is called principal diagonal. Now in principal diagonal, you see, upper triangular means elements below the principal diagonal are 0. Lower triangular means elements above the principal diagonal are 0. Triangular matrix means either this can be called as triangular or this can be called as triangular matrix. The next diagonal matrix means the elements other than the principal diagonal must be 0. Yeah. And scalar matrix means in the principal diagonal all entries must be same, remaining 0. And unit matrix means it must be 1 in the principal diagonal, remaining are all 0, right? So after this, dear students, before we talk about trace of a matrix, trace of a matrix in the sense, it's very simple. In a square matrix, suppose A is a square matrix, 5 1 0 3 2 5 1 1 3 something is given. Trace means we write like, trace means trace of A is simple, sum of the elements in the principal diagonal. Trace means sum of the elements in the principal diagonal. That means here 5 plus 2 plus 3, which is 10. Clear? So all this discussion is about the principal diagonal related. Clear everyone? Those who have understood, thumbs up. Yeah, those who understood, thumbs up. Come on. Come on, those who understood the definitions. Yeah, yes, yes, come on. And many didn't like the video even, many didn't like, many are watching but didn't like the video. Yes, unit matrix is also a scalar matrix. It's a special case of scalar matrix. Scalar matrix is a special case of diagonal matrix. Diagonal matrix is a special case of triangular matrix. Okay, what is the difference between diagonal matrix and scalar? In a diagonal matrix, principal diagonal elements can be any. Okay, in a scalar matrix, all must be same. Got the point? In a scalar matrix, all these elements must be same. In a diagonal matrix, all these must be 0, but diagonal you can have any elements. Got it? Got it everyone? Got it? Yeah. Yes, they will repeat these concepts in the college, but it's better here I am giving it, since it's a bridge class, I am giving this in a very slow pace. So this is why, yeah. So this is all for you. Fine. Equality of matrices, dear students. Okay. Two matrices are said to be equal. Two matrices are said to be equal. Suppose, dear students, you see this matrix, this is 1, 2, 3, 10, one matrix. This is 1, 2, 3, 10, one matrix, and you can write 1, 2, 3, 10, another matrix. So let it be A, B, C. Can I say that out of these, which can be equal? That is my question. Which matrices are equal? So dear students, we define equality of matrices like, if at all you want to say two matrices are equal, do remember their order must be same, the corresponding elements must be same. You see, since 1, 2, 3, 10, 1, 2, 3, 10 same elements are there, you cannot say that these two are equal because its order is 2 by 2, its order is 1 by 4. First of all, if you want to say two matrices are equal, their order must be same. Second thing, corresponding elements must be same. That means 1 same, but here 2, here 3, not same. A not equal to C, friends, not same. Order okay, but since the same numbers are shuffled, you cannot say that bhaiya these two are equal matrices. Okay? Got my point? If at all you want to say two matrices are equal, you must say their order must be same and corresponding element must be same. In fact, its equal matrix must be the same, nothing other than this. Okay? Nothing other than this. Once again, let me say here, you try to answer this. Suppose if A, B are two matrices, its order is m by n, its order is p by q. Suppose these two are equal, you can immediately say m must be equal to p, n must be equal to q. Moreover, the corresponding elements must be equal. Okay? For example, dear students, a matrix is like 3x, y, 6 is equal to a, 2, 4, b. If you see these two matrices are equal, that means corresponding elements are equal. So 3 must be equal to A. A is equal to 3. A is equal to 3. And x must be equal to 2. X value is 2. 3 value is A. Y value is 4. 6 value is B. Correct? Correct? Correct everyone? Correct? Yeah. Before I introduce algebra of matrices, yeah, one important point, you tell me which matrix is big. 2, 3, 4, 5 is matrix A, B is 1, 4, 6, 7, 8, 9, 1 minus 1, 6. C is 200, 300, 400, 500. Okay. Now dear students, can I say that B is greater than A? Am I correct or wrong? B is greater than A, correct or wrong? B is, many of you didn't like the video, didn't like the video. Yes, many of you didn't like the video. So, dear students, B greater than A, right or wrong? Right or wrong? Yeah, dear students, yes, I appreciate the students who are saying wrong. Yes, because since order is big, I cannot say that it is a big matrix. Now, can I say that C greater than A? C greater than A. Now you tell me C greater than A, correct or wrong? Come on, quick, text. C greater than A, right or wrong? 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 Yeah. Fine. So we got 50% right, 50% wrong. Okay. One important point I tell you, do remember everyone, one important point please do remember, matrices are not comparable. There is no meaning saying big matrix, small matrix. Correct? Matrices are not comparable. There is no meaning to say big matrix, small matrix. Comparing greater than or equal to, smaller than as meaningless completely. Got my point? Got my point? So, dear students, matrices are not comparable. Big matrix, small matrix is no way meaningful here. Got it? Yeah. So, dear students, so let us, an algebra of matrices will do tomorrow. Tomorrow we are going to give addition, subtraction, multiplication, determinant of matrices. Before that, let us recall all the important points that we have discussed today. Point number one, okay, all of you see, number one, what is a matrix? A matrix is arrangement of mn elements in m rows and n columns. That means some elements in rows and columns is a matrix. First point is that. Okay. Second point, element address. Suppose it is in first row and fourth column, we write the element A14. An element Aij means it lies in ith row and jth column. It lies in ith row and jth column. Okay. Right. Next, size of a matrix or order of a matrix. Order of a matrix is nothing but number of rows by number of columns. Okay. Yeah, before you said A of m and n must be equal to corresponding, no sir. And then what is the difference between those two matrices? Which two matrices, Neha? Before you said A of m by n must be equal to, means, you are talking about equality of matrices, we will discuss now, dear students. I mean to say it is a matrix of order 2 by 2. Now, based on the order of the matrix, there are, we can say, rectangular matrix means rows are different from columns. Square matrix means rows is equal to number of rows is equal to number of columns. And row matrix means there is only one row. Column matrix means there is only one column. And I forgot to explain about zero matrix or null matrix. Zero matrix can be of any order where all entries are 0. So, null matrix or zero matrix. It is a 2 by 3 zero matrix. Okay. You can also write 2 by 2 null matrix. Null matrix or zero matrix is that matrix whose all entries are 0. It can be of any order, right. A zero matrix or null matrix is of, yeah, Sir, when equated, we can tell this one is largeness. No. You see, they are not defined. We didn't define which is greater matrix, which is smaller matrix. Okay, they are not defined. So we don't define. If we define, we can say something that is not necessary. So it is not defined. Right, null matrix. Okay. After that, dear students, if matrix Aij definition is given, we can write the matrix. We can construct the matrix. After that, we define the principal diagonal in a square matrix. In a square matrix, principal diagonal is Aij, where I is equal to j. Observation is the elements above the principal diagonal will have I less than j, below the principal diagonal will have I greater than j. Then next, with respect to principal diagonal, we define upper triangular matrix means all entries below the principal diagonal must be 0, and lower triangular means all entries above the principal diagonal must be 0. Triangular matrix means it may be either upper triangular or lower triangular. The next, diagonal matrix means we also write like this: the elements other than in the principal diagonal must be all be 0. These can be any elements. Scalar matrix means it is also a diagonal matrix, but all entries are same in the principal diagonal. Okay. Next, unit matrix means all entries must be same, that too equal to 1 in the principal diagonal, remaining are all 0. And null matrix is a matrix whose all entries are 0. It need not be a square matrix, it can be of any order. Okay, right. Trace of a matrix is nothing but sum of all elements in the principal diagonal is called a trace. Next, A is equal to B. Two matrices are said to be equal if they have same order and corresponding elements same. Means they must have same order, corresponding elements same means A11 must be equal to B11, A12 must be equal to B12, like that. Then only we say that those two matrices are equal. Okay. The next, matrices are not comparable. So there is no definition like big matrix, small matrix, positive matrix, negative matrix, like this. We didn't define mathematically. Okay. So algebra of matrices is going to be done tomorrow. Tomorrow's class is very, very important, dear students, because I am going to tell you how to add, subtract, that is fine. Multiplication of matrices and determinants, a very, very important thing for computing certain things. Initially, even physics also it is required. So don't miss the class. And everyone, all of you, follow the classes, practice the things. See you, dear students. Catch you. Thank you. Bye. Bye, everyone. Bye. Stay tuned to Sri Chaitanya, and chemistry sir is waiting for you. Will be joining in couple of minutes. Stay tuned to Sri Chaitanya. Bye.